hopefully blah blah blah. Not below draw the label of forces. So we got this, we got this, we got that, we got that. So there's FA, FF, FN, FG. Did I miss anything? I think that's it. Notice it says not components, so do not crack gravity. If you crack gravity, you will lose points. Not because it's wrong to crack gravity, because you are too stupid to read the directions. Is that insensitive? Yeah. So if you take that test where like one of the things is like the first direction is read all the questions before starting the test. Yeah. And then like there's all these stupid things like get up and quack like a duck. You know, like stand on your chair and flap your arms, squawk like a chicken, like do all these dumb things. And then the last thing is this last question on the whole test is disregard all of these directions and sit quietly. They always do that in home memory school, I'm for sure you did. Alright, check it. What's that one?
Basically, it is designed so.
Oh, yeah. Because they made literacy a requirement for voting. Which, I think in an honest world, that's a good thing. Because if you can't even read or write or think, how could you? Yeah, whatever. Okay, anyways. Yeah, it was designed to screw it over. Alright, calculate the normal force on the plane of the block. So we want this, F sub n. So then I'm saying some of the forces in the x, and when I say x, I mean this way. So the sum of forces in the x is 0. Some of the forces in the y is 0. So we have FA is equal to, just go ahead and mg sine theta, and over here we have Fn, that's not correct, I'm missing something, plus f sub f, yeah, and then Fn is equal to mg cos theta. So, yeah, normal force, yeah, so that's all I have to do. I mean, did they give us numbers? Are there numbers? Oh yeah, we'll just plug everything in. Magic. Alright, calculate the component of the force of gravity acting in the box's parallel to the plane. That also is relatively simple, mg sine theta. Calculate the friction force between the plane and the box. They say how much the guy, so the frictional force is going to be Fa minus mg sine theta. Do you remember that the AB test, not always, but oftentimes guides you through the question. Did I mention this yesterday? It leads you through the question. Look what they asked us to do in part C. And then what do you do with this? You use it in part D. You see that? What's that? Calculate the, oh, well, yeah. I mean, I haven't translated F sub F into new F sub N yet. But, oh, okay, thank you. Thomas even highlights my point further, because I didn't finish this before I stopped on my little tangent here. But F sub F is going to equal mu F sub N, right? So that means we're at mu mg cos theta is equal to Fa minus mg sine theta. So you see, this was part B, and this was part C. Okay, so that happens a lot. So if you have no idea how to move or proceed in the question you're at, look at the questions before. And a lot of times, it's like they're leading you into that, how to do the answer. All right, but does this statement make sense? Questions? Okay, I'm assuming a lot, so I'm hoping that you're being intellectually honest. Okay. But yeah, because we gotta go. It's just take the four statements, plug everything in. All right. Calculate the force applied by the person on the box. So then that's just solving for FA. Let me take a look at this. Okay. They give us the mass of the box. So that's 50 kilograms. And we know that mu is 0.30. Okay, so, yeah. So F sub F is no problem because F sub F is mu mg cos theta. So we can solve all that. Yeah, that's fine. And then solving for FA, it's just taking that statement where we said FA is equal to FF plus mg sine theta. So then just combining this and mg cos theta. All right, that's good. So once again, calculate the force applied by the person. Use the force statement that we already said. Part B, the normal force, is just mg cos theta. Part C, the moment of gravity acting parallel, that's mg sine theta. The friction force is mu mg cos theta. Right, so we don't need our full force statement yet. This is where we need it, right? Because FA is equal to FF plus mg sine theta, which means FA is mu mg cos theta plus mg sine theta. Okay, so just using our force statement, which we all mastered back in September. Then calculate the work done by the person pushing the box, assuming I would just use the easiest thing, and I would say the work is going to equal to the change in potential energy. Okay, if you go up 3 meter ramp, they give you the height, I think, right? No, the height's 3 meters. Actually, is the energy equation. Yeah, so you do have to put the work done by friction. So that's nice. Yeah, so it's going to come out. So then the total work is going to be mgh plus the force of friction times the distance. And of course, we don't know, I don't think they give us the distance. I think it just gives the height and angle, right? Yeah, so then mgh is going to equal, oops, mgh plus mu mg cos theta, and then d should be H is something like the H over sine theta. Drag this down a little bit. Yeah. So this, some red. Okay. Sine of theta is H over. Confuse you. So let's call that y. It's y over h for hypotenuse. If you want to do it by how it looks on here, but if you call this h, you call it d. That works. So it's going to be h over d. So then d is h over sine theta. That's where I got that from. So it's just mgh plus the work force, the force applied times the distance that was applied. Very nice. Sorry? Sure. You can take the force that you calculated by the person. Yeah, taking E. It works too. Because the person's overcoming friction to make it move. Wait. Oh yeah, and just to get the total work, just take the force by the person times the distance. Because then person should be overcoming a force of gravity. Okay, cool. Either way, so whether you do an energy statement or whether you do this by the person, that works. So, ready?